Now a trivial extension of this would actually be to say, what if n is equal to 3? Nothing prevents me from creating an architecture that basically looks something like this: 0, 1, 2, 0, 1, 2, etc. Right? Whatever, I can do anything that I want over here. So for example, I can just continue to feed a of n, b of n at time 0. Similar connections could have been made. I can use time 2 if I want instead. But there are some question marks over here. So for example, if I connect it at time 2, what happens at time 1? Okay, and more importantly, the output that was generated at time 0 straight away came out at R out at time 1. What will be there at time 2? I don't know. It does not correspond to any input because I have not specified what is there at time 1 on the inputs to the adder, right. So if I want correct functionality, what I will actually need to do over here is to say I need to add one more register. Now what will happen is, at s equal to 0, this will get an plus bn. At s equal to 1, this will get an plus bn, and at s equal to 2, this will get an plus bn, which in turn will come over here and get added correctly with the cn which is coming in on s equal to on the other input of the adder. Okay. So in other words, what ended up happening over here was I needed to add one extra register out here. In other words, if n is equal to 3, 2 registers are needed to make sure that the functionality comes out correctly. Okay. So just to make sure that you understand exactly that what is happening over here is clear, let us just look at this a bit more carefully. I am just going to write down the main parts of the sequence. I have A0, B0, I will call this out 1, out 2, and this one can be R out. So out 1, out 2 will basically, out 1 will be A0 plus B0, which at time 1 will come here to out 2, and at time 2 will come here and in turn will sit here. Okay. As long as I give C0 over here, this will in turn lead to this becoming A0 plus B0 plus C0. So what happens over here, I really do not care what these values are because I am never going to use them. So clearly this is, so two parts to this. One is functionally this is correct because I have made sure that the A0 plus B0 as well as the C0 came at the correct instants of time so that the computation happens properly. But it is also a waste because I ended up using 3 cycles when 2 was sufficient. So why would I do something of this sort? Probably never. You are not likely to actually want to do something of this sort, right. This was only a demonstration to show that if necessary, functionality can be achieved, required functionality can be done correctly. On the other hand, it also tells us something more, that there is this business of finding out the number of registers that I need on different edges. How long do I need to store a certain value before it gets used? Because clearly, unlike a purely combinational circuit where I just give all the inputs and everything just gets computed and comes out, over here I am doing partial computations and I am storing them somewhere. How long should I store them? For how many clock cycles do I need to store each value? Do I need to store everything for n clock cycles? Do some values only need to be stored for 1 cycle or 2 cycles? Determining all of that is the most crucial part of translating those time instants at which the different operations are executed into a complete hardware architecture.